wet blanket with Waptec. In the year 2022, over a fairly long period of time, it seems, from 2017 to 2018, there were reports in the news, and even a week ago, people are reposting these news stories, that in the year 2022, you will see a binary star merger-induced red supernova. This will be a lot like 2002's Monocerotis, which is that explosion that you see years and years ago where people would show this ever-expanding ball. It's called it's a light bubble. It's also called V838. And they showed that for years and said that's a star coming towards us, and every fearmonger in the world used that image. But KIC 9832227, a binary star, is not going to explode and be visible in the year 2022. Doesn't matter how far away it is, and doesn't matter what else you might have heard, for a simple reason. There was a prediction of the binary stars falling into each other by the year 2022. Now, this is something that can actually be tested and predicted, and it was based on raw data. The trouble is, there's something that's a giant red flag about it. The orbital period of the two stars orbiting each other was a little under 12 hours. Now, what you have to do is you have to look at how often they eclipse each other, which causes a little wobble in the brightness level, and detect if there's a time change. Now, if let's use the ends of my fingers. If they're offset a little bit and go around each other and we don't see anything, we see both of them, we can't tell that there's an orbital change much. If they eclipse each other, we get pulses twice each orbit. If it's 12 hours or 11 hours, that means you have two stars orbiting each other in half a day. All right? So that's some pretty heavy torque going on. But it is still twice a day. But the problem is, one of the data sets that was used to figure out there was a change in how fast they were orbiting each other was wrong by exactly the same number of hours as the orbit almost. It was off by 12 hours or so. What that meant is that when one set of light detectors detected this part of the eclipsing, the other set would detect this part, but they were from the same period of time. Somehow or other, the data sets were offset just enough to show that the orbital period was changing. They weren't using one observation point because we're on a planet orbiting the sun and it's rotating on its axis. They have to figure out exactly when to take that same picture to see that same frame. And if it's off a little bit, it's going to show wavering. When they corrected for it and put the information back in, they found out that from the year 2013 to 2017, instead of it becoming a faster and faster and faster rotation, it was getting slower, which means it's less likely for them to collapse on themselves, and in fact shows that they're probably getting further away from each other, which means this is a binary star system that's cycling its orbital sizing over many, many years. And it had been increasing, getting bigger from 2013 to 2008, and then reducing and then changing again. What it means, it's an unstable binary star system. Now, why am I bringing this video up? Again, the prediction of a merger was based on it happening in 2022, based on a mathematical model of two stars orbiting each other almost 11 hours on the cycling time, and a reduction from 2013 to 2017, but almost exactly all of the information was wrong because from the year 2008 forward, it showed it was getting longer. So all it's doing is it's getting slower and then speeding up about the same amount. It's not showing a linear progression. It's showing an orbital pattern for two stars orbiting each other that's, while it's really fast and really a fracas, it's unstable. It doesn't mean they're going to merge at any time, especially saying they will merge in 2022 is wrong. And I mean, literally, it's just wrong. We don't know if they would ever merge. That could have been doing this for a very long time. They're still observing it. And since 2018, they've been observing it. And it's still showing variation. It's not reducing or increasing the orbital timing. It's doing both. They're changing all over the place. What that means is we're probably looking at, from top down, a couple of stars doing a little dance around each other that are exchanging momentum with each other and flinging themselves through space in some way that we don't understand. Or it's a binary star system with planets. Planets don't have to orbit a star in the same way you think they do. So, and the planets could be far enough away that they could be at an offset to where, like I said, if two stars are orbiting each other but we don't see it at the correct angle, you have to see it at this angle to see them eclipsing each other. What if the stars are orbiting like this, but the planets are orbiting in an extreme offset like this where we can't even see them eclipse? There could be a couple of planets throwing the thing off center. The stars could be orbited or co-orbiting with a very large gas giant or an uninitiated star that hasn't fired up yet. Don't know. Now, again, in 2002, Monocerotis, which sounds like a medical problem, otherwise known as V838, blew up. It did the same thing this was thought to do. And it was spectacular. And they got images of it. And the shockwave of the flash of light from it expanded throughout space in an area with lots of gas and dust and lit it up and made it incandesce at probably hot enough to make it actually burn stuff. I mean, you wouldn't want to be near a supernova. And that created this expanding shell effect that people assumed for some reason is Nibiru coming at us. So that will be in the title of the video. That's all there is to it. The original prediction was based on data being interpreted wrong. Once it was interpreted right, it was found that it's yet another binary star system that isn't stable, and there's 100 billion things that could be causing it. Now, what people did after they found out we're not going to see this, and they couldn't make money off it on YouTube, they made videos anyway. They said that science doesn't know everything. Yeah, but you're getting your evidence from science, and then they said, oops, we effed up, we got the timing wrong. Again, when you take photos at night, pointing a camera into space, looking at a star, or a pair of them, timing may be incredibly important. Having it be wrong by 12 fucking hours, meaning the orbital period taking 12 hours to do this, means that you could make an error right between this and this being the frame to figure out whether or not they're orbiting at a different speed. And I'm actually pretty sure they were using something besides something based sitting on the planet. I mean, they could have been using the Hubble, but it doesn't matter. There isn't going to be a supernova in 2020 from it. The prediction was based on science making mistakes and then correcting itself. There's no sign of it accelerating its orbital speeds or whatever. And my little glib statement about an extra gas giant around it is mostly because I wanted to make a joke about burritos. Thanks for watching. Have a good day. Good luck with that.